Okay, so more shading inequalities. This time they're both quadratics. So again, my first step is to actually shade the quadratics. So y is greater than x squared plus 4x minus 12. So that factorizes, which is nice. So plus 6 and minus 2. So let's start sketching them over here. In fact, I think I'll probably find the roots of the other one first, just so then I can try and make sure I can get them both on the same axes. So this one is actually the difference of two squares. So it is important to spot that. So 2 plus x, 2 minus x. So I've got a root at 2 and minus 2. So they're both right. So yeah, that's important to note. They've both got a root at 2. So one of them is, so let's sketch this one. So this one has got a root at minus 6, 2, and a y-intercept of minus 12. Okay, and then the other one, well, it's a negative x squared, so it's going the other way, and has roots at 2, minus 2, I'll sketch it in a different colour, and a y-intercept of 4, so that will do for my sketch. That's okay. So y-intercept of 4 and x-intercepts of 2 and minus 2. Right, so then let's shade in green. So shade the region that satisfies inequalities. So we want values of y greater than this one and less than this one. So because it's not very easy to rub things out on this without rubbing my diagrams out, I'm actually just going to go straight to sketching the region they want. What you might do is, if you're not totally sure, sketch that region, so sketch everything above that quadratic, then sketch everything below the other quadratic, and then just keep the bits where it overlaps. Okay, so that's our overlapping region. It just says shade. Sometimes it says things like label it R, but it just says shade. And then the other thing to consider, both of these were strict inequalities, so we are including the quadratics, so they're fine to be solid lines. I don't need to sort of go back and change those to dotted lines.